Balance the redox equation using half reaction method. The equation given is MnO4 minus plus Sn2 plus giving Mn2 plus Sn4 plus. First let us identify the oxidation equation and then the reduction equation. We can see Sn2 plus here is getting converted to Sn4 plus. So there is an increase in oxidation number from 2 plus to 4 plus. So we will write that again. First Sn2 plus giving Sn4 plus. That is the oxidation half of the equation. The next one is MnO4 minus giving Mn2 plus. Let us find the oxidation number of MnO4 minus. Let X be the oxidation number of Mn manganese plus minus 2 is the oxidation number of each oxygen atom. There are 4 oxygen atoms into 4 giving minus 1 is the overall charge equals minus 1. So X minus 8 equals minus 1. X equals minus 1 and this minus 8 will become plus 8 when it comes here. So it will be plus 7. So there is a change in oxidation number from plus 7 in MnO4 minus of manganese to plus 2. So that means it is getting decreased. So that is the reduction reaction. That is MnO4 minus giving Mn2 plus. Now let us take each of these reactions individually. That is MnO4 minus giving Mn2 plus. First let us look at the atoms other than oxygen or hydrogen. So which are the atoms present? It is manganese, Mn. Both sides are having one manganese atom each. So that means the number of manganese atoms are balanced. Now let us go for the oxygens. There are 4 oxygen atoms on the left hand side. So in order to add 4 oxygen atoms on the right hand side, we can add 4 molecules of water. That is how we balance oxygen atoms. So 4 oxygen atoms are now added to the right hand side. Now there are 8 oxygen atoms, 8 hydrogen atoms, 4 into 2, 8 hydrogens on the right hand side. We have to add 8 hydrogens here. So for that we add 8 H plus ions on the left hand side. Now oxygen atoms, hydrogen atoms, then manganese, all atoms are balanced. Let us look at the charges. Here we have 2 plus or plus 2 charge on the right hand side. Water is not having any charge on it. So plus 2 on the right hand side. What about the left hand side? We have minus 1 and plus 8 H plus ion. So plus 8 here on the left hand side. Plus 8 and minus 1 will give us a resultant of plus 7. So there is a difference of plus 5. That is, here it is 2 plus or plus 2 and here it is plus 7. What is the difference between plus 7 and plus 2? 5, isn't it? So that 5, that positive 5 or plus 5, we can balance by adding 5 electrons to the more positive side. This is plus 7 side and this is plus 2 side. So we will add 5 electrons to the more positive side. Now the charges are balanced. Let us just look. This is 5 electrons. So minus 5 and this minus 1 will make it minus 6. Minus 6 plus 8 will make it plus 2. Here also we have plus 2 charge. Okay, so that equation is balanced. Now let us take the oxidation half reaction. Sn2 plus giving Sn4 plus. Only the charges need to be balanced. Here we have left hand side it is plus 2 and right hand side it is plus 4. So how do we make it plus 2 like the left hand side? We can add 2 electrons to the more positive side. More positive side is this because it is having plus 4. This is having plus 2. Now minus 2 from the 2 electrons. Minus 2 and plus 4 will make it plus 2. And here it is plus 2. So both sides are balanced now. Now we have something else to do. When we look at this, we can see there are 2 electrons here and 5 electrons there. One on the left hand side and the other on the right hand side. We have to make the number of electrons the same so that we can remove these electrons, because in the final equation there shouldn't be any electrons. So in order to remove these electrons, if we make them the number of electrons the same, we can cancel them out. Okay, so let us multiply the first equation by 2 and the second equation by 5. And multiplying and writing the equations, we can get 2 into 5, 10 electrons. 10 electrons plus 2 into 8, 16H plus 2 MnO4 minus giving 2 Mn2 plus 4 into 2, 8 H2O. That is the first equation. The next one we should be multiplying by 5. 5 Sn2 plus giving 5 Sn4 plus 5 into 2, 10 E minus. So we have made the number of electrons the same in both the equations. Now we can cancel out these electrons. And now we can add these two equations together. Let us write it. 2 MnO4 minus plus 5 Sn2 plus 16H plus. That indicates that this is in the acid medium, giving 2 Mn2 plus 5 Sn4 plus 8 H2O. So this is the balanced equation for the acid medium. Now if we want to convert it to the basic medium, what should we do? In the basic medium there should not be any H plus ions. So how do we remove these H plus ions? We should be adding an equal number of hydroxyl ions or OH minus ions. So when adding OH minus ions, we have to add the same number of OH minus ions to the right hand side also. So let us write that equation once again. That is 2 MnO4 minus plus 5 Sn2 plus 16H plus. Now let us add 16 OH minus ions, giving 2 Mn2 plus 5 Sn4 plus 8 H2O plus 16 OH minus. Okay, let us see if we can make some changes. This 16 H plus and 16 OH minus ions will give us 16 H2O molecules, water molecules, isn't it? H plus and OH minus. So let us rewrite the equation as 2 MnO4 minus plus 5 Sn2 plus 16 H2O giving 2 Mn2 plus 5 Sn4 plus 8 H2O plus 16 OH minus. Now again we have a little bit of work left. There are 8 H2O molecules, water molecules on the right hand side. We can cut them and make this 16 8. So 16 H2O minus this 8 H2O. We have got 8 H2O on the left hand side. We will rewrite the equation. 2 MnO4 minus plus 5 Sn2 plus 8 H2O giving 2 Mn2 plus 5 Sn4 plus 16 OH minus. So this 16 or OH minus ions indicate that this is in the basic medium. So this is the balanced equation for the redox reaction in the basic medium. So first we did it in the acid medium and then we converted it by adding as many H plus OH minus ions as there were H plus ions, and then we converted it into the basic medium.